In my previous two videos, we looked at how to configure the 555 timer chip in the monostable and astable modes. In this one, we'll be looking at how to configure the 555 in the bistable mode. As you may remember, in the astable mode, the 555 had no stable state, and in the monostable mode, it had a single stable state. In the bistable mode, it actually has two stable states, both high and low. The bistable multivibrator circuit that I'm showing here is sometimes referred to as a flip-flop or SR latch. We use the term flip-flop because it can alternate between the two stable states. It flips to one state, it will remain there indefinitely until a trigger is applied, and then once the trigger is applied, it flops back to the first or original state. So in other words, a flip-flop circuit like this, when a short pulse on the trigger pin causes the output to go high, it stays high, even after the trigger pulse stops. The output will then stay high until a reset pulse is received, at which time the output flops back to the original state. Let's take a closer look at how the circuit works. One of the first things you might notice when you look at the schematic is that, unlike the monostable and astable modes, we don't use a resistor-capacitor circuit to set the timer in motion. And that's because there is no timing in this circuit. There's just the two stable states, high and low, which are controlled directly by the trigger and reset pin inputs. Both the trigger, pin 2, and the reset, pin 4 inputs are connected to our voltage rail, and they're kept high through the two 10 kilo ohm pull-up resistors. When I push the trigger, or the set switch, pin 2 is shorted to ground, which means that the voltage supply bypasses pin 2, gives a short low pulse that triggers the 555. And just like in the monostable mode, when the trigger pin is at a low voltage, the output goes high. And in my breadboard circuit here, I have the output lighting an LED. Both of the internal comparators are now low, and so the output will remain high or on until the voltage at the threshold pin reaches above 2/3 of the voltage supply. Since we have the threshold pin 6 going directly to ground in this circuit, it never reaches 2/3 of the voltage supply, it can't, and so the output can remain high indefinitely. But if I press the reset switch, the timer is reset by a low pulse on the reset pin, pin 4, and the voltage at the reset pin goes to ground, the pin goes low. And of course, when the reset pin goes low, the output goes low or off, and it will remain off until a new trigger pulse is received. And that's it in a nutshell. The two stable states are controlled by the set and reset switches, which temporarily ground trigger pin 2 and the reset pin 4. Now, in terms of practical applications, I think it's worth briefly talking about digital computers and specifically memory, because these flip-flops are basically 1-bit storage systems. When we configure a 555 timer in the bistable flip-flop mode, as I've done here, with the output going to an LED, it's acting as a memory cell to store 1 bit of data. The SR flip-flop, sometimes referred to as an SR latch, is a basic sequential logic circuit with two inputs, one which will set the device, giving an output of 1, and one which will reset the device, giving an output of 0. This type of flip-flop, or latching circuit, gets used a lot in computers, but that's not to say the 555 is a good choice for computer applications, because in a typical computer, a clock pulse is used to drive the trigger and reset signals, and the frequency of the clock signal is very high. We're talking gigahertz. The output of the 555 timer wouldn't be responsive enough to match the speed of the clock signal's frequency. But there are much faster flip-flop devices available which can be used for those high-speed applications, but the principle is the same. You'll no doubt encounter many other applications for this flip-flop circuit though, where high-speed responsiveness isn't a critical factor. But that's it for this video. Thanks for watching, and please click like. Don't forget to subscribe if you'd like to see more content like this soon.